we're asked to convert the Cartesian coordinates -1, -1 to polar coordinates. So while we do have formulas for this, so I'll just go ahead and state those real quick. So we want to go from the format x comma y. So we want to go from describing it in a point in terms of how far to the right of the origin do you need to go, how far up or left and down, whatever direction that might be. We want to convert that to talking about a point in terms of its radius on a circle and its angle. So earlier we established a formula. We said that, or we were able to uncover that the radius is equal to, well, how do we find the radius? We determined that that ends up utilizing Pythagorean theorem, and that we could take the square of the x-coordinate plus the square of the y-coordinate, square root that, and that will give us the value of r. So this is an r here. And then theta is equal to the inverse tangent of y over x. Well, the cool thing is you never really need to memorize that. You actually know everything you need to know in order to be able to find these. So all I'm going to do is I'm just going to go ahead and draw a quick rectangular graph and say, well, we want to know the point -1, -1. Okay, so that's where it is. Now we know that this point is going to fall along some circle. So roughly speaking, it's going to look something like this. And this is the point that's going to be represented on a circle. The only problem is we don't know how far it is from the pole, from the origin. That is, we know how far to the left and how far down we need to go, but we actually need a radius. We need to know the distance directly from that point to that point on the circle. Okay, well, we do a little bit of algebra here, and not even so much algebra as our understanding of right triangles, and we convert this thing into a right triangle. So kind of what we've already done. Well, we know that if we went straight up from that point and we went straight to the right, that would get us to the origin, and that forms a right angle here. Okay, well, we already know that what the purple side lengths are. We know that this is over -1. This guy is down 1. And so we basically need to solve for the hypotenuse. Well, the hypotenuse is really the radius. And we know that the hypotenuse, sorry, I won't use hypotenuse, I'll call it the radius, that the radius squared is equal to the side squared plus the side squared, which in this case, the side, well, one of them is the x squared, plus the other side is really just the y squared. And that's what the radius squared is, but I need the radius, not the radius squared, so I have to solve for r, and that becomes x squared plus y squared. So it's not really that difficult to derive. In fact, you could actually just be plugging in the numbers as you go, and you could say, all right, well, the radius squared is -1 squared plus -1 squared. So down here we would end up, if we did it at the end, plugging in -1 plus -1 squared. And -1 squared is 1, -1 squared is 1, so we get square root of 2, which is approximately 1.4. So basically that distance from that center to that point is 1.4 units. Now similarly here, if we think about it in terms of, well, we're trying to find this angle right there, so we know that we have the opposite and we have the adjacent of that angle. So what I can write is, I know that opposite over adjacent is what tangent of theta measures. So in this case, tangent of theta is equal to y over x, because y is the opposite and the x is the adjacent. And so now we can solve for theta. Well, to solve for theta, you have to take the tangent inverse, and that becomes the tangent inverse of y over x. So really not that hard to derive these. You don't really need to memorize these. We just need to know a little bit about right triangle trigonometry, which is what we've been studying in this class. And so that should become pretty straightforward in terms of that derivation. So the inverse tangent of y, well, y is -1, x is -1, and the inverse tangent of that becomes -1 over -1 is 45 degrees. So that's something you can enter into your calculator. Just make sure you're in degree mode if you're going to represent the answer in degrees. And tangent inverse of -1 divided by -1 is equal to 45 degrees. And so we are done. Our point that we were looking for is, it's a point with a radius of 1.4 and an angle measure of 45 degrees. But there's one minor problem. And that minor problem is that this really isn't 45 degrees, right? 45 degrees is somewhere up here. So the actual angle we're getting is this corresponding to this point over there. So what do we need to do? Well, we know that this angle right here is 45 degrees, so that must mean that this angle here is 45 degrees. So actually in order to get a point that's in the third quadrant, well, what do I need to do? Well, I know that's going to be 180 degrees plus something. In this case, it's 180 degrees plus 45 degrees, which is 225 degrees. So really we have to double check our answer. We can't just spit things out into the calculator because it's possible that that might not be in the correct quadrant. So our actual point is going to be 1.4 comma 225 degrees.